Hello guys. So today we struggled a bit with our entrance ticket and it's kind of okay because we didn't end up um using this for class today. We finished the lesson from yesterday in class, but tomorrow we are definitely going to need to know how to find the slope of these graphs. So the biggest thing that I feel like a lot of people messed up on was a lot of you guys were looking for just something different, like which of these don't belong. But that's not really what it was asking. Because you could come up with different reasons for why something doesn't belong, but I'm asking which one of these relationships, like the relationship itself, is different from the others. So I want which one, and I'll reword it tomorrow for tomorrow's entrance ticket. Tomorrow, I'm going to say which one of these relationships has a different slope than the other three. Okay. So I wanted you guys to find the slope of these three graphs and then figure out which one does not have the same as the other two. A couple of you guys did do the right thing of trying to find the slope using the slope triangle. And I saw a couple people, so just like yesterday's video, when I'm looking for the height over base or the vertical over horizontal here, this is going from 0 up to 4. We don't want to pay attention to what the boxes are doing. We want to pay attention to the numbers. So this is 0 up to 4 has a height of 4. Going over here, again, I don't want to pay attention to the boxes. I want to pay attention to the numbers. So I'm going from 0 all the way over to 0.8. So my height or my vertical distance is 4. My horizontal distance is 0.8. And you probably would have needed to use a calculator for this. So tomorrow, if you have one like this, you don't know what 4 divided by 0.8 is, you can use a calculator. And 4 divided by 0.8 is 5. So the slope of this line is 5. If I was to go all the way over to 0.1, it would match up with 5 over here. Okay? So the slope of this line is 5. This line here is going up by 10s on the y-axis and going over by 2s on the x-axis. So I am drawing my slope triangle here. My vertical is going up to about between 50 and 60, so I would say that that's 55. Okay, from 0 up to 55, so it's from 0 to 55 is 55. Going over this way from 0 over to 10, 10 would be my horizontal. So this would be 55 over 10, and 55 divided by 10 is 5.5. So now I see I've got one that's 5 and one that's 5.5. So let's keep going and see what these other two are. This one here, I'm going up by 10s on the y-axis, but going up by 2s on the x-axis. So I can see my vertical distance here going from 0 up to 20. I'm not counting the boxes. I'm looking at the number. So I'm going up to 20. And going over, I'm going from 0 over to 4. So my horizontal is 4. So vertical of 20 divided by my horizontal of 4. 20 divided by 4 is 5. So this one's 5, this one's 5, this one's 5.5. So let's see if this one is also 5 or if we get something completely different. So this one's even trickier because it looks completely different from the other ones. It's super, super steep, but that's only because our y-axis is going up by 20s and our x-axis is going up by 20s. So I'm going to draw my slope triangle. The height is from 0 up to between 40 and 60 is going to be 50. So 0 up to 50 is a vertical of 50. My horizontal here is going from 0 over to between 0 and 20, between 0 and 20 is 10. So I've got 50 over 10. 50 divided by 10 is 5. So the graph that has a different relationship is B because it has a different slope. Okay? B has a different slope. Again, that means A, C, and D, they are all the exact same line. The only difference between A, C, and D is the scaling, the way X and the Y axis are scaled. So the reason why they look super different is because this one here is zoomed in really, really close. This one here is zoomed out really, really far. That is the only reason why they look super different. If you guys have any questions about this before class, please let me know. But you guys will have another entrance ticket tomorrow to kind of make up for this one.